Hi, welcome to Raw Math. Today I'm doing a series of videos on rational functions. This question says, find all the vertical and horizontal asymptotes for the following functions. List any holes, then graph. All right, so for the vertical, I always start with the vertical asymptotes. We take the denominator, x plus 5, we say that cannot be 0. So in this case, we have x cannot be negative 5. If we put this into the numerator, 25 minus 15 plus 7, that's not going to give us a 0. So negative 5 is not a 0 of the numerator, so we don't have to worry about trying to factor the numerator. Now, you might look at this and say, well, 1 times 7, 1 plus 7, it's not factorable, but we don't even need to test it if the 0 of the denominator doesn't go into the numerator. That's my point. Okay, as for horizontal asymptotes, so we're going to call the numerator n of x for the polynomial, the denominator d of x, and d, very complicated. The dimension of the numerator, we're going to compare that with the dimension of the denominator, d of x. This is dimension of 2, because it's a square as its leading term. This is a dimension of 1. The numerator is greater than the denominator. There is no horizontal asymptote. No horizontal asymptote. But because this is exactly 1 degree larger, there is a slant asymptote. To find a slant asymptote, we need to divide. Now, because we have this really simple denominator, we can use synthetic division. We can say, put negative 5 into the box. Our coefficients are 1x squared, 3x, and 7. Add down and multiply. Add down and multiply. Add down. This being our remainder. And because this is a squared, we end up with x minus 2 plus 17 over x plus 5. This is another way we could write h of x. So this right here becomes our slant asymptote. So we come down 2, our slope is 1. So our slant asymptote is y equals x minus 2. Our vertical asymptote is, x equaling negative 5. We barely have any of this on our graph since I don't have a x equaling negative 5. We could bring this out a little bit further just so that we have something to graph down here. All right, then if I want to graph the actual function, which I can also do here, I need to plot a few points. So I'm going to go down a little bit further. I'm going to rewrite my function, the original one, h of x equals x squared plus 3x plus 7 over x plus 5. And then the way I'm going to graph this is I'm going to do a table of values. So I have x and h of x. My asymptote is at -5, so the values I'm going to choose are going to be right around that -5. So I'm going to choose -7, -6, not -5, -4, -3, -2. Now, when I do this, I can plug these in directly into my calculator. I have a bit of a smarter calculator, so I hit my mode button, then I hit 7 for table, and I'm going to put in to my calculator parenthesis for numerator, and then alpha all the way down here, right above parenthesis, there is this x, alpha x squared plus 3 alpha x plus 7, close parenthesis, divided by parenthesis alpha x plus 5, close parenthesis. And then just like I said before, I want to start at -7, so -7. I want to end at -2. I could do a step of 0.5 if I wanted more points. I don't really need them, so I'm just going to say a step of 1. And then I can get -17.5, -25. Notice 5 is an error because that's my asymptote. And then I have 11, 3.5, and 1.6 repeat. All right, so I have some values here. I'm not really going to graph them all. I'm going to notice that -7 is like way down here, and then 6 is even further down. So what that means is this graph is going to look something like this. I'm off of the graph. I know I have an asymptote. I'm approaching on both sides. -4 is at 11. That is also off my grid. -3 is at 3.5. Hey, something I can actually plot. -2 is at 1.6. So this is coming up here. 0, by the way, is at 1.4. I do have that in my notes. So 1.6, 1.4. And I have a basic sketch of what this graph looks like. So this is how I can take this function and graph it. I get my slant asymptote, I get my vertical asymptote, and I could have just done the basic sketch knowing what I know. I like having a few points to kind of guide so I don't go too deep into this V and I don't get too deep into this V. I can kind of use a few points to help guide where I put the graph itself. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel and I'll see you on the next video. Thanks!